AI spending projected to increase to $2.59 trillion in 2026, up 47% over year to year, and only going to increase. There's also an article in Real Clear Politics. A plurality of Americans want data center construction halted. These are AI data center construction. 50% cite a drain on their resources as a concern. 18% cite water usage as a concern. 18% cite energy consumption as a concern. Others cite broader environmental impacts. When did AI data centers become the enemy? My guest is my business associate, on whose board I sit, Chairman and founder of APIC Corporation, Dr. Raj Dutt. Raj, thank you very much for taking the time.
Oh, absolutely. It's an honor and a pleasure always, Larry, to be with you.
First question is, how's business?
Well, as you well said, the reason we have so many enemies is because the business is booming. AI is here to stay globally. There's no way out. It's like, in 2008 or so, when the internet became a hot commodity, every company was adding .com and off and running with it. And as you know, that was a Defense Department technology called the ARPANET. And I happen to be one of the original guys who got started with the ARPANET. And so AI is the same thing, it's going to move forward. There's no way around.
The energy that propels AI and robotics and these hypercomputers is expensive. Talk to us about APIC's role in lowering the cost of this kind of energy.
Well, one of the reasons we got started in this technology area was because the US government felt that this issue needed to be handled, at least in terms of big computers. And they felt that it was absolutely essential for the warfighter to have similar machines, but would take significantly lower power and much smaller in size. That's what the government wanted. So that's how we got into the business, because we had amazing technology that we had developed for the Joint Strike Fighter. And the US government, a portion of it, especially in the intelligence world, felt that was important. And so we figured out how to drop the energy consumption by a significant amount, and also to make the computers work faster and make them a lot smaller.
Now, for those of us listening and watching, Raj, who are not physicists, explain how this technology was developed and what exactly it does.
So the way this technology works is, in conventional computers, you have electrons moving information on copper wire, either on a board or inside a computer chip. You have what you call the transistors, and they have a lot of movement of information that is done through electrons. When electrons propagate on copper, they generate heat. It's as simple as that. It's high school math, I squared R heating. The challenge was, can we replace that movement of information, that communication, for small movements in computers and on the boards where the computer movement of information is? Can you replace them with fiber? And if you could successfully do that, then that flow of information would be non-disruptive because there was no heat generated. So it was a disruptive technology, but had an amazing capability if you could do it. And we figured out how to do that.
And it's cheaper.
It's significantly cheaper when you go to volume production. Initially, like all R&D technologies, it takes time to get to the volume. But the commercial market is massive. It's like any of these things. The Defense Department, the Department of War actually now, needs things to be better and smaller and less power. And you develop it for them. But then there's a massive commercial market once you've cracked the code. And so, and that's what we have done, is using photonics, uh, particles of light, to move around that information. And as photonics on fiber for moving data has been done globally. You know, now information that flows around our planet Earth is through fiber. But it was important to try to figure out how to do that on the computer at the chip scale level, which is very, very small. And we have been developing those chips, and we got the patents for those chips. And then subsequently, the government said, we need the systems. And so we figured out how to build the systems using that technology. And that has massive savings in power and latency and size.
A couple more questions, Raj. As you know, SpaceX just went public, creating the first trillionaire in the history of the world.
Yes.
It's about space exploration, maybe going to the moon, colonizing the moon. Do you have anything to do with that? Does your technology have anything to do with that? Will your technology have anything to do with that?
It's a very good question. Excellent question. The answer is yes, and why? It is fortunately, when you get movement of information using particles of light, for space, it saves weight, less energy, but there's an added benefit, and that is photonics and optics network on a satellite does not allow electromagnetic pulse like a nuclear explosion, the EMP that comes out of it, or a single event upset like a gamma ray to come in, or the solar outbursts that happen on a regular basis. That can actually not only disrupt communications within a satellite, but can also burn all the electrical. So what we do is, by doing that for the satellites, you're going to drop the amount of
45 seconds.
weight,
45 seconds, Raj.
the amount of weight that you'll have to send up in space. And then there's a natural benefit, which is it is hardened. You don't have to put metal sheeting to prevent radiation from coming in and destroying.
What is the website if people want more information about APIC?
It's apicchip.com. www.apicchip.com.
Raj, thank you so much for coming on. I'll see you this weekend.
Thank you, my friend.
You're buying.
Appreciate it. Okay. You're on, brother.